repellant forces or dispersion forces we say, which are weak attractive forces among the molecules. Now the second type of intermolecular forces are dipole-dipole forces. The dipole-dipole forces we could see among that polar molecules or dipole molecules having that dipole, like hydrogen chloride, water molecule, carbon dioxide molecules we say. So the molecules having the dipoles, partial charges, right? It's particular example we say hydrogen chloride, we say H2O, we can write the example because they are polar molecules, they generate partial positive charges which is less than the complete electronic charge we say, which is complete electronic charge is 1.6 into 10 to the power of minus 19 coulombs is the complete charge. That means 1.60202 into 10 to the power of minus 19 coulombs is the complete charge of that electron. Less than this charge is said to be partial charge we say, fraction of charge we say, that is indicated with the symbol is delta symbol, delta negative or delta positive. The delta indicate discrete or less than the charge, less than this is charge of one electron, less than this charge is said to be delta positive or delta negative we say, negative. Okay, so and the dipole forces compared with the dispersion forces are very strong we say. These are the strong forces operated between dipole molecules like HCl and HCl. So when these molecules, that means if you take the polar molecules and among the polar molecule there is a strong interaction is stronger, and this interaction will develop attraction forces between this is HCl and this is HCl, and so HCl has one side positive charge, other side is negative charge, means one side is partial positive, other side is means towards hydrogen is partial positive, towards chlorine is partial negative. Such molecules come closer at the critical distance. What happen means among between this molecule, negative attract the positive and positive attract that negative, so automatically between them, so attraction forces will form, attractive forces will form, and those attractive forces are said to be dipole forces. So when the distance between them, the distance increases, the force of attraction, this is force of attraction decreases. When the force of attraction is increasing, in the sense the distance is decreasing, so the attraction force, dipole interaction depends upon the distance separated by the molecules we say, or we say. That means, so the force is equal to 1 upon R cube if you consider the stationary molecules, and 1 upon 6 if you take the rotating molecules. That means the force of attraction, dipole interaction, is 1 upon R to the power 3 for the stationary molecules in the solid, 1 upon R to the power 6. So we say this is for the rotating molecules. This is for what means the stationary molecules. The dipole-dipole interaction depends upon 1 to the power of 1 upon r to the power 3, the stationary molecules, polar molecules. If the dipole-dipole interaction energy depends upon 1 upon r to the power 6, if the molecules rotating polar molecules we say proportional. Okay, so this is about what we call dipole-dipole interaction that takes place among the polar molecules to form particular state of the matter, particularly liquid we say. Another intermolecular forces is said to be dipole induced, so dipole forces we say. And the dipole induced dipole forces generally happen between, so this dipole and the dipole induced forces, attractive forces we could see in the permanent dipole molecule. Between permanent dipole molecule is mixed with non-polar molecule we say. Non-polar molecule symmetrically having that electronic system, and permanent dipole system, this is the polarized molecule we say. This is what is the polarized system? Because so AB is a molecule, so this is that A is a molecule, for example. This is so A, this is A is a molecule, this is AB is a molecule which has a permanent dipole, and it is not having any dipole we say. It has it is symmetrical, this is a distorted one. When this, so in the polar molecules, if you put this non-polar molecule, automatically the non-polar molecule is polarized. This is called induced dipole will takes place. The permanent dipole will distort this what we call non-polar molecule electronic system. Then so this molecule also polarized. Then once it is polarized, between them there is attraction force is operated. That attraction force between this permanent dipole molecule and non-polar molecule is said to be what we call means induced dipole attraction force we say. Dipole and induced dipole attraction forces we call. So and the molecules having larger size easily polarized. The polarizability so depends upon the strength of what means permanent or strength of the attraction forces we say, attraction forces. And the last one, intermolecular forces, is about hydrogen bond. This is also one type of van der Waals force, and so this is a special case of dipole-dipole interaction. This is the special case of dipole-dipole interaction, and it is found in the molecule in which a high polar NH bond is there, OH bond is there, HF bond is there. That means if the hydrogen attached to the most electronegative group, what is that? Nitrogen, most electronegative nitrogen, and oxygen and fluorine. These are the most electronegative nonmetals which are present in the molecules and causes hydrogen bonding. And this hydrogen bonding is also attraction force between hydrogen and most electronegative species, nitrogen, oxygen, fluorine, and even chlorine also. And this hydrogen bonding, and the hydrogen bond, so energy varies from 10 kilojoules to 100 kilojoules per mole. Now look at this molecule H2O. H2O is attracted to hydrogen of another H2O molecule. See, one water molecule will make how many bonds? You can check 4 hydrogen bonds it can make association. That means here if the molecules, permanent dipole molecules having nitrogen atom, oxygen atom, and so chlorine atom, so these will attract the hydrogen atom partially, and making that bond is said to be so hydrogen bond we say. This hydrogen bond classified into 2 types. One is inter-hydrogen bonding we say, inter-hydrogen IHF B, hydrogen bond we say. Then is second one is intra hydrogen intrahydrogen H B. These are the two types of hydrogen bonding we say. That means when two polar molecules containing electronegative atom and hydrogen atom, so facing together between them attraction force. For example, the oxygen between oxygen and hydrogen there is hydrogen bonding attraction force, and so the hydrogen between hydrogen and oxygen there is attraction force, and hydrogen and oxygen attraction force. As a result of this, what happened means association of molecules takes place. For example, fluorine HF is the compound between this fluorine and the hydrogen there is hydrogen bonding is formed. This is intermolecular hydrogen bonding. So between the two identical molecules, between hydrogen and fluorine, there is intermolecular force of attraction. Between hydrogen and oxygen, so between the two different molecules, two same molecules. So this is one water molecule, this is other water molecule, between them attraction force. This is the hydrogen bonding, which is represented with the dotted lines. This is hydrogen bonding, we say. So what is the effect of this hydrogen bonding? Means the hydrogen bonding affects the physical state of the compound, we say, particularly liquids. So, and also the hydrogen bonding decides or determine the boiling and the melting points also. Let us take one example. There is a compound called salicylaldehyde. Salicylaldehyde is the compound having the benzene ring. There is a OH functional group is present, then CHO is the functional group is present. The CHO aldehyde functional present is ortho position, and the oxygen becomes very close to the hydrogen on the same OH. Between hydrogen and oxygen there is attraction force. This is called intramolecular hydrogen bonding. Molecule is associated between this oxygen and hydrogen of the same molecule. So this is what we call means intramolecular hydrogen bonding, attraction force between this within the molecule. This is the attraction force. And if you look at this one more molecule, if OH group is at fourth carbon, NO2 group on the first carbon, and another molecule also NO is below, OH is above, opposite direction they are facing. Between this hydrogen and oxygen there is intermolecular hydrogen bonding. Here also there is intermolecular hydrogen bonding. This is intermolecular hydrogen bonding. The same thing also takes place. Here is aldehyde group is present, here is OH group is present, then aldehyde group OH will attach to this hydrogen, and aldehyde group facing this OH. So attraction force will develop, then it is said to be what we call means intermolecular hydrogen bonding, we say. So then always intermolecular hydrogen bonding affect more boiling point. Matlab, so always the intermolecular hydrogen bonding increase the boiling point of the liquid than the intramolecular. That means boiling point of the liquids depends upon the hydrogen bonding, we say. Intermolecular hydrogen bonding will increase the boiling point of that liquids. So this is about intermolecular forces and thermal. So we'll discuss the thermal energy and later. So because thermal energy talks about that, so motion of the particles. Okay.